In this video, we will study how to reduce a matrix A to the PAQ form. Here, what we have to understand is if A is a matrix of rank R, then there exist two non-singular matrices P and Q such that PAQ is in the normal form, which means matrix IRO equals PAQ. Now the procedure of obtaining P and Q from matrix A of order m by n is we first write A equals unit matrix of order m as a prefactor of matrix A and In is its postfactor. Then we perform row transformation on A and the same on unit matrix Im and or column transformation on A and same on the postfactor In so as to convert this matrix A to an identity matrix of rank R, which finally reduces this matrix A to the normal form. In the end, this prefactor becomes P and this postfactor becomes Q, and we are able to tell the rank of matrix A as it gets converted into the normal form. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Before we discuss reduction of a matrix A to normal form PAQ, let me tell you a little bit about elementary transformation. This is for those who know about elementary transformation but struggle a lot in carrying out the transformations. Following strategy will help a great deal. First, we will talk about elementary row transformation. In elementary transformations, we generally convert a given matrix A into a unit or identity matrix of the same order. Suppose we want to convert a matrix of order 2 ABCD to identity matrix. Then we have to plan our row transformations such that first this element A is reduced to 1, then this element C is reduced to 0, then element D is reduced to 1, and finally this element B is reduced to 0. If we are given a 3 by 3 matrix A, B, C, D, E, F, G, H, I, and when we want to convert this matrix into identity matrix of the same order 3, then we have to plan our row transformations in such a manner that we first convert this A into 1, then this D and G each 0, then we have to convert this A into 1, then this B and H into zeros, then we have to convert this I into 1, and finally this C and F to 0 each. If we are given matrix of order 4 A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, we have to plan row transformations. First we have to convert this A to 1, then this E, I, M each to 0 in one step or in multiple steps. Then we have to convert this F to 1, then this B, J and N to zeros in a single step or in multiple steps. Then we have to make this K 1 and this C, G and O each 0 in a single or multiple steps, and finally we have to convert this P to 1, then this D, H, L into 0 each in a single step or in multiple steps. In column transformation of a 2 by 2 matrix ABCD, as usual, this first element A is made 1, then instead of C, B is made 0, then D 1, and finally C 0. In case of a 3 by 3 matrix A, B, C, D, E, F, G, H, I, as usual, this A is made 1, then B and C each is made 0, then this E is made 1, then this D and F is made 0 each, and finally this I is made 1, then this G and H is made 0 each. In case of a matrix of order 4 A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, this A is made 1, then this B, C, D 0 each, then this F is made 1, then this E, G and H is made 0 each, then this K is made 1, then this I, J, K is made 0 each, and finally this P is made 1, then this M, N and O is made 0 each. So this type of strategy helps a great deal in reducing a given square matrix into unit matrix of the same order. We can note one thing: when we are performing row transformation, we are essentially converting columns, and when we are performing column transformations, we are essentially converting rows. That you must have understood by now. While converting a matrix A to the normal form, we are planning our row transformations or column transformations in such a manner that a unit matrix of rank R is maintained in the left top corner of the resulting matrix, while the remaining elements in O are zeros. This we have already understood. So therefore, unlike elementary transformations to convert a matrix A to a unit matrix of the same order, our attempt should be, or we should plan our row transformations or column transformations such that as far as possible the rows from bottom upwards or columns from right to the leftwards are converted to 0 rows or columns respectively, so that finally a unit matrix of rank R is created in the left top corner of the matrix. For doing so, you may or may not use the strategies to convert a given matrix A to the unit matrix of the same order that we have discussed just now. Moreover, you cannot mix the operations of row transformations and column transformations together, which means you can start column transformation after you have completed row transformation, or you can start row transformation after you have completed column transformation. So these are some of the tips that I think you should keep in mind. We are given matrix A as 1 1 1 1 minus 1 minus 1 3 1 1, and we will convert this matrix A in the form PAQ as the normal form, and hence we will find rank of matrix A. So we start by writing matrix A equals its prefactor I3, then A, then its postfactor I3. We have A as 1 1 1 1 minus 1 minus 1 3 1 1. Then we write unit matrix 1 0 0 0 1 0 0 0 1. Then we write A, its postfactor, another unit matrix 1 0 0 0 1 0 0 0 1 of order 3. Our aim is to convert this matrix into normal form. So first we will reduce these two elements to 0. For that we will perform row transformations R2 minus R1 and R3 minus 3R1 on A, and same row transformations on this prefactor, and we will write this postfactor as it is. So we write the first row 1 1 1 as it is, then R2 will be 1 minus 1, 0, minus 1, minus 1, minus 2, minus 1, minus 1, minus 2. 3 minus 3, 0, 1 minus 3, minus 2, 1 minus 3, minus 2 equals, now this prefactor becomes, with the same row transformations, first row will remain the same, 1, 0, 0. Second row will be 0 minus 1 minus 1, 1 minus 0, 1, 0 minus 0, 0. Then 0 minus 3 minus 3, 0 minus 0, 0, 1 minus 0, 1. Then we write A and this post factor as it is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now we will make these two elements of equivalent matrix A 0. For that we will perform column transformations C2 minus C1 and C3 minus C1. So that will make the first column will remain the same, 1, 0, 0. In the second column 1 minus 1, 0, minus 2 minus 0, minus 2 minus 2 minus 0, minus 2, 1 minus 1, 0. Because of these two zeros, the third column will remain as it is, equals, now we have to perform these column transformations on this post factor and we will write this prefactor as it is. So we write 1, 0, 0, minus 1, 1, 0, minus 3, 0, 1. Then we write A and after that we perform column transformation on this post factor of A. So it will become, the first column will remain as it is, 1, 0, 0. C2 minus C1 will make the second column 0 minus 1 minus 1, 1 minus 0, 1, 0 minus 0, 0. C3 minus C1 will make 0 minus 1 minus 1, 0 minus 0, 0 and 1 minus 0, 1. Next we have to make this minus 2 equals 1. So for that we will perform minus half R2 on this equivalent matrix A and this prefactor of A, but we will write this post factor as it is. So minus half R2 will be, the first row and third row will remain as it is. So we write 1, 0, 0. The third row 0, minus 2, minus 2. And the second row will become minus half into 0, 0, minus half into minus 2, 1, minus half into minus 2, 1. The same row transformations we will perform on this prefactor. So once again we write the first row 1, 0, 0 and the third row minus 3, 0, 1 as they are, and minus half R2 will make minus half into minus 1, half, 1 into minus half, and 0 into minus half will be 0. Then A, and as decided we will keep this post factor the same. So 1 minus 1 minus 1, 0, 1, 0, 0, 0, 1. Now we have to convert these two elements of R3 equals 0. So for that we will perform R3 plus 2R2 on this equivalent A, and it being row transformation the same on the prefactor, but we will write the post factor as it is. So R3 plus 2R2 will make the first row 1, 0, 0 and the second row 0, 1, 1 the same. The third row will become 0 plus 0, 0, minus 2 plus 2 will be 0, minus 2 plus 2 will be 0, equals, we will perform R3 plus 2R2 on this prefactor. So the first row 1, 0, 0 and the second row half minus half, 0 will remain the same. In the third row it will be minus 3 plus 1 minus 2, 0 minus 1 minus 1 and 1 plus 0, 1. Then we write A and this post factor as it is. So it will be 1 minus 1 minus 1, 0, 1, 0, 0, 0, 1. Finally we have to make this element of equivalent A 0. So for that we will perform column transformations because we have these two zeros in the second column. So we will perform C3 minus C2, that will give us this equivalent matrix A as 1 0 0 0 1 0 0 0 0 equals, since we are performing column transformation, the prefactor will remain the same. So we write 1 0 0 half minus half 0 minus 2 minus 1 1, then we write A, and we have to perform C3 minus C2 on this post factor. So we write the first two columns 1 0 0 and minus 1 1 0 as they are, and the third column will be 0 minus 1 minus 1. We will demark the elements here like this. That gives us this equivalent A as I2 O O O equals, this will be matrix P, then this A, and this matrix Q. So therefore we got this matrix as P, this matrix as Q, and matrix A in the normal form, this. So we have rank of matrix A equals rank of this unit matrix, which is 2. So we got matrix P, matrix Q, and rank of matrix A, which is 2. For the given matrix A, 1 1 2 1 2 3 0 minus 1 minus 1, we have to find non-singular matrices P and Q such that P A Q is normal form of A. So we start by writing A equals I3, the prefactor of A, and I3, the post factor of A. I3 is a unit matrix of order 3. So that will be 1 1 2 1 2 3 0 minus 1 minus 1 equals, I3 will be 1 0 0 0 1 0 0 0 1, then A, then the post factor 1 0 0 0 1 0 0 0 1. We will make these two elements of the first row 0. For that we have to perform column transformation C2 minus C1 and C3 minus 2C1. First column will be same, C2 minus C1 will be 1 minus 1 0 2 minus 1 1 minus 1 minus 0 minus 1. C3 minus 2C1 will be 2 minus 2 0 3 minus 2 1 minus 1 minus 0 minus 1 equals, the prefactor will remain the same, 1 0 0 0 1 0 0 0 1, then A, then same column transformations on this post factor. First column will remain the same, C2 minus C1 will be 0 minus 1 minus 1 1 minus 0 1 0 minus 0 0. C3 minus 2 C1 will be 0 minus 2 minus 2 0 minus 0 0 1 minus 0 1. After that we will make these two elements 0, that is this one 0. For that we will perform R2 minus R1, that will give us the first and third row will remain the same. So 1 0 0, the third row 0 minus 1 minus 1, the second row will be 1 minus 1 0 1 minus 0 1 1 minus 0 1 equals, the same row transformation on the prefactor. We write the first row and the third row as they are. The second row becomes 0 minus 1 minus 1 1 minus 0 1 0 minus 0 0, then A, then the post factor will remain as it is. So 1 minus 1 minus 2 0 1 0 0 0 1. Next we have to make these two elements in C3 0. So we perform C3 minus C2. So that gives us the first column and the second column will remain the same. In the third column 0 minus 0 will be 0, 1 minus 1 will be 0, minus 1 plus 1 will be 0 equals, the prefactor remains the same. 1 0 0 minus 1 1 0 0 0 1 A. For C3 minus C2, first column 1 0 0, second column minus 1 1 0 will remain the same. C3 minus C2 will give minus 2 plus 1 minus 1 0 minus 1 minus 1 1 minus 0 1, and finally we have to make this minus 1 0. For that we perform row transformations R3 plus R2. The first two rows 1 0 0 0 1 0 will remain the same. In the third row 0 plus 0 0 minus 1 plus 1 0 0 plus 0 0 equals, we will perform R3 plus R2 on this prefactor. We write the first two rows the same. R3 plus R2 will be 0 minus 1 minus 1 0 plus 1 1 1 plus 0 1, then A, and the post factor will remain as it is 0 1 minus 1 0 0 1. Now we will demark the elements like this. That gives us I2 for this unit matrix 1 0 0 1, then O, then O, then O, which is the normal form, equals, this is matrix P, then A, and this matrix Q. So this is the normal form, then non-singular matrix P, non-singular matrix Q, and rank of A from this normal form 2. In case of reduction of a matrix A into normal form PAQ, the matrices P and Q may not be unique because they depend upon elementary transformations used. If we use different transformations than what we have used here, we will get different matrices P and Q. If you like this video, please share this to your classmates. Don't forget to subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.